You know, for farmers and growers, some of the biggest battles they face aren't against droughts or storms. No, they're against an invisible enemy that's waging a war right under their feet. So today, we're going to dig into a really powerful, natural strategy to win that war, a technique that actually turns the soil's own biology into a weapon.
And that's a really serious question, right? When your entire livelihood depends on what you can grow in the soil, how in the world do you protect it from threats you can't even see? This has been a huge challenge for agriculture for, well, centuries.
The bad guys in this story are microscopic, but believe me, their impact is massive. We're talking about soil-borne pathogens, a relentless force that threatens our global food supply.
And if you want to put a number on it, try this one on for size. That's the estimated crop loss every single year caused by just one type of these pests, plant parasitic nematodes. $157 billion. That's just a staggering figure, and it really shows you the scale of this underground battle.
So who are these culprits? Well, we're talking about devastating fungi like fusarium and verticillium. These things can make crops wilt and just rot from the inside out. Then you've got harmful bacteria, and of course, those super costly nematodes. And the worst part, these pathogens are incredibly resilient. They can form these tough little structures and just hang out in the soil for years, waiting. For a long time, the go-to solution was heavy-duty chemical fumigants like methyl bromide. But those are being phased out because of their environmental impact. So the old weapons are disappearing, and growers desperately need a new strategy.
And that brings us to the hero of our story, a powerful ecological solution called Anaerobic Soil Disinfestation, or ASD for short. It's a completely different way of thinking about soil health.
So what is it exactly? Well, ASD is an ecological alternative that basically turns the soil's own microbial community into an army against the bad guys. It's sometimes called biological soil disinfection. And here's a cool fact. It was actually developed independently in both Japan and the Netherlands. Now that's a crucial detail because it proves the core principle works in totally different climates and soil types. This isn't some niche trick, it's a truly global solution.
This quote really captures the core idea perfectly. You're essentially feeding the good microbes, drowning out all the oxygen, and then just letting nature do the dirty work for you. It's less about sterilizing the soil and more about hitting a reset button on the biological balance.
It might sound complicated, but the process on the ground is actually remarkably straightforward. It really just breaks down into 3 fundamental steps.
Okay, step 1, you mix a carbon source, something like rice bran or molasses, into the soil. Think of this as the fuel for the whole process. Step 2, you irrigate the soil until it is completely soaked, pushing out all the air. And finally, step 3, you cover the whole thing with an airtight plastic tarp and just leave it for about 3 to 6 weeks. That's it. Fuel, water, and a lid. Simple.
This diagram here really connects all the dots for us. We start at the top with the process, right? Adding organic material, soaking it with water, and covering the soil. This kicks off all the mechanisms you see in the blue box, like a total lack of oxygen in the production of these toxic organic acids. And those mechanisms lead directly to all the positive impacts in the orange box, killing pathogens, suppressing weeds, and improving the soil's overall health and fertility. It's a beautiful, interconnected system. And here's what it looks like in the real world, out on the farm. You can see the machinery mixing in that fresh organic matter. Then the irrigation creating that saturated, oxygen-free environment. And finally, that huge expanse of plastic film sealing the deal. You're basically creating a massive field-scale fermentation chamber. Okay, so what is the magic happening under that plastic tarp? The science is just fascinating. We're essentially creating a controlled fermentation process right there in the field. Now this chart, I know it looks a little complex, but it tells the whole story of the biological war that erupts in the soil. Don't worry about all the different lines for now. Just look at the general trend. You see in the bottom graph how the oxygen just disappears almost immediately. Well, that triggers a massive shift in who's living in the soil, the microbial populations you see in the top graph, and that's the key to this whole thing. So, in phase 1, which happens super fast, the aerobic microbes, the ones that need oxygen to live, they go on an absolute feeding frenzy with that carbon source we added. They multiply like crazy, and in the process, they use up every last bit of oxygen in the soil. They basically set the stage for their own demise.
Once all the oxygen is gone, the anaerobes take over. These are the microbes that thrive without oxygen. As they start feasting on all that organic matter, they release this cocktail of organic acids and gases. And this chemical brew is what does the real work. It's toxic to a whole range of pathogens, fungi, and nematodes, and it effectively cleanses the soil from the inside out.
So, the science is really cool, but what about the actual results? Does it work? Let's take a look at the proven impact of ASD, both the incredible benefits and, some of the real-world challenges.
The track record is impressive to say the least. As this table shows, ASD is proven effective against a whole spectrum of major agricultural headaches. We're talking pathogenic fungi, bacteria, those really destructive root knot nematodes, and even tough weeds like nutsedge. See, it's not a silver bullet for just one thing, it's a broad-spectrum solution.
And here's what I think is the most important takeaway. Unlike chemical fumigants that just sterilize everything, killing both the good and the bad microbes, ASD is way more selective. It targets the pathogens while at the same time enriching the beneficial microbial communities. This creates a healthier, more resilient soil ecosystem that leads to better crop yields for the long haul.
Now, one of the most practical benefits of ASD is just how flexible it is with its fuel source. The carbon can be anything from wheat bran and molasses to poultry litter or even leftover plant material from cover crops. The key point here is that growers can often use whatever is cheap and locally available, which is fantastic because it can turn agricultural waste into a really valuable resource.
But, of course, it's not a perfect silver bullet for every single situation. It's really important to have a balanced view. While ASD is an amazing ecological alternative that improves soil health, its effectiveness can vary. It's pretty sensitive to temperature and the type of soil you have. It can also be a little less effective against pests that live really deep down in the soil profile. And you do have to take that land out of production for that 3 to 6 week treatment period, which is a big consideration.
So, after looking at the problem, the process, and the results, it leaves us with a pretty fascinating question, doesn't it? Is this method, basically fermenting the earth on a massive scale, is this the key to a more sustainable future for farming? It's a really powerful idea. Instead of fighting nature with harsh chemicals, we might just be able to harness its own complex microbial processes to create healthier soil and a more secure food supply for all of us.